This is Lesson 5.3, Adding Fractions, and Lesson 5.4, Adding Mixed Numbers. Okay, if Amir ate 1/3 of a small peach tart, and Kaylee ate 1/3 of another peach tart that was the same size, together, how much peach tart did they eat? 1/3 plus 1/3 equals 2/3. Okay, then if Chase ate 1/3 of a small peach tart and Quinn ate 1/3 of a large peach tart, together did the boys eat 2/3 of a peach tart? Did you say no? No, because our wholes are not the same. This 1/3 cannot be added to this 1/3 to make 2/3. Because our wholes are not the same. Let's solve another problem. Listen to my story. Jenny's teacher assigned 12 math problems for homework. Jenny finished 3/12 of the problem at school. She solved 2/12 when she got home from school. All right, let me get out my 12ths. Separate them. Jenny finished 3/12 of the problems in school and 2/12 when she got home. And I'm going to get rid of my other pieces that I don't need. So the question is, how many problems, or rather, what fraction of the problems has Casey solved so far? First, what's my whole? The teacher assigned 12 math problems for homework. My whole is 12 math problems. She finished 3/12 in school and 2/12 at home. Do our fractions refer to the same whole? Yes, they do. They refer to the 12 math problems. All right, 3/12 plus 2/12. Let's get my pencil. We are adding 3/12 plus 2/12. All together, that gives me 5/12. Did Jenny finish less than half the problems, more than half the problems, or exactly half the problems? 5/12 is less than half. Let's look at this same problem on a number line. My number line is divided into 12 equal parts. 12/12 makes up my one whole, the homework assignment. So Jenny finished 3/12 in school. Three 12ths. 1, 2, 3. She finished 3/12 of the problems in school, and then she finished 2/12 at home. That brings us to 5/12. Let's look at mixed numbers. 2 1/4 would be equivalent to how many fourths? So I'm on the eTools on ConnectEd, and I'm going to pick the fourths showing my one whole, 2 wholes, and 1/4. Here's my 2 1/4. What would that be equivalent to in fourths? How many fourths to make up 2 1/4? 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 1/4 is equivalent to 9/4. I decomposed into unit fractions. And let's look at that on a number line. 2 wholes and 1/4 can decompose into 9/4. This is a fraction greater than 1. So starting at 0, I'm going to jump 9/4. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9/4 on my number line that's divided into fourths, and I land on 2 and 1/4. So these are visual representations for you to understand mixed numbers. 2 and 1/4 in fraction circle pieces, 2 and 1/4 on my number line broken up into fourths. Let's solve a story. The cafeteria had 2 3/5 tubs of grape jelly and 1 1/5 tubs of strawberry jelly. How many tubs of jelly in all? First thing I'm going to think about is what is the unit fraction? My unit fraction would be 1/5. What's the whole? My whole are tubs of jelly. One tub of jelly is my whole. Now, what number model would I do? Two 3/5 plus 1 1/5 to find out how much jelly in all. Now, does it matter if I add my whole numbers first and then the fractions, or add the fractions first and then the whole numbers? Well, it doesn't matter because of the commutative property of addition. That's our turnaround rule. So let's go on ConnectEd and see this problem visually. I need fifths. I need 2 wholes and 3/5. Here's my 2 3/5 in fraction circle pieces. Plus 1 whole and 1/5. Break them apart, keep 1/5, and oops, lost them. Here we go. I'm going to keep 1/5, and I'm going to get rid of the other ones. So here I have visually with my fraction circle pieces, I have 2 3/5 plus 1 1/5. What would my total be? Let's see. I have 3 wholes and 4/5. I have 3 4/5 tubs of jelly. I could also have added my unit fractions to see how many fifths in total. This is 5/5, 10/5 altogether, 15/5, 16, 17, 18, 19/5. 19/5 is equivalent to 3 4/5. 19/5 is a fraction greater than 1. And let's look at this on a number line. My number line is divided into fifths. From 0 to 5/5 is 1 whole. Here's my 1 whole. Here's 2 wholes. So we are going to start at 2 3/5. From 2 3/5, I need to add 1 1/5. 2 3/5 is my starting point. How many fifths altogether will I need to jump? Well, let's think. 1 whole. How many fifths would make 1 whole? 1 whole is the same as 5/5 plus my fraction plus my 1/5. So altogether my 1 1/5 is 6/5 that I'm going to need to jump on my number line. So starting at 2 3/5, I'm going to jump 6/5. Here we go. 1, 2, 3, 4, 5, 6. I started at 2 3/5 on my number line. I decomposed 1 1/5 to find out how many fifths I needed to jump forward. 6/5, and I land on 3 4/5. So we have 3 4/5 tubs of jelly in all. In lessons 5-3 and 5-4, we will be working with adding fractions and adding mixed numbers. Remember, you can go on to ConnectEd and build number lines and use fraction circles to help you to visualize these problems. See you in class.